Hi everybody, it's Manila. Welcome to my channel. In this video, I'm going to talk about chirality center and absolute configuration of a chiral atom and a molecule, which is an important topic in organic chemistry. So chirality, when a molecule is non-superimposable on its mirror image. So for example, we have the first image here, which is an image of a flask. It has a plane of symmetry, which means that one side of the flask is exactly the same as the other side. If you put them on top of each other, they will overlap. This structure is called a chiral structure. Our hand does not have a plane of symmetry and one side is not the same as the other side. So we can call this structure chiral structure. This applies to molecules and chemistry as well. For example, I have a molecule here. It's a carbon attached to 4 different groups and its mirror image. So these two structures, they are chiral structure because they do not have a plane of symmetry and they won't overlap if we put them on top of each other. If we want to find the chiral center in a molecule, we need to follow 2 rules. First, we need to find the atom that is attached to 4 different groups, and this atom should have sp3 hybridization. For example, 2-butanol. So the center carbon is attached to 4 different groups, which are methyl, ethyl, hydrogen, and alcohol. So this carbon is attached to these 4 groups in a single bonding position. So this carbon can be a chiral center in a molecule. For example, this carbon here, we have this carbon attached to 4 different groups, which are alcohol, hydrogen, ethyl, and chlorine. So this carbon is also attached to 4 different groups, and these groups are bound to the carbon with a single bonding position. So this carbon can be also a chiral center in a molecule. Here are some examples. The first structure here is the chiral center. Because this is the only carbon that is attached to 4 different groups. It's attached to the carbon with a single it's attached to the carbon which has a double bond with oxygen. It has a hydrogen atom which is invisible in this picture, and also the methyl group, and also another carbon down over here. The second structure that we have here, the second molecule, here is the chirality carbon. I have already indicated that because that's the only chiral center in this molecule. The other atoms are either involved in double bonding position or they are attached to two or more identical atoms. In the third example, here's our chiral center because this carbon is attached to 4 different groups in a single bonding position. And also, this molecule has another chiral center as well, which is right over here. This carbon is also attached to 4 different groups and in a single bonding position. I have some examples here for you guys, so feel free to pause the video and come back. The first structure that we have is carbon attached to 4 groups. So the groups are different because we have bromine, hydrogen, fluorine, and iodine. So this structure can be chiral structure, and the carbon in the center can be chiral center in a molecule. The second structure that we have is carbon attached to 4 groups, but 2 groups are identical, which are methyl groups. So this carbon cannot be a chiral center in a molecule, and this structure is called achiral structure. The third one is the same as the second one. We have 2 identical groups attached to this carbon, and this carbon cannot be a chiral center in a molecule, and this structure is called achiral structure. So these are the answer for all of them. So the first one is chiral, the second one is achiral, and the third one is achiral as well, because the carbon is attached to 2 identical atoms. Okay, so let's go to the naming system. RS naming system, this indicates the absolute configuration of a chiral atom. First, what we're going to do is we're going to assign the priority groups to the atoms that are around the chiral center. Then the lowest priority group should be pointing away from us, and the highest priority group should be pointing towards us. And then we're going to look for the direction that the priority decreases. So in the direction that priority decreases, if it's clockwise, it's R configuration, but if it's counterclockwise, it's going to be S configuration for the center of chirality. And these priority groups are going to be based off atomic numbers of each atom. For example, I have listed a few atoms over here. The lower priority group is hydrogen because the atomic number is 1, and the higher priority group is bromine because the atomic number is 35 in this list. So we're going to give number 1 to bromine and then number 4 to hydrogen. And hydrogen should be pointing away from us and bromine should be pointing towards us. For example, in these 2 structures, they are mirror image of each other. So let's do the first one, the first structure. So let's assign the numbers of priority for the first structure. Chlorine will get the first one because it has a higher atomic number among all these atoms that are attached to the carbon. second one goes to oxygen, third goes to carbon, and the fourth goes to hydrogen, because hydrogen is the lowest atomic atom. Has the lowest atomic number among all these atoms that are attached to the carbon. So the direction is clockwise direction. So this is our configuration. The second structure that we have here is the same thing, is the mirror image of the first molecule. So the first number goes to chlorine again, second goes to oxygen, third goes to carbon, and the fourth goes to hydrogen, because hydrogen is the lowest atom. And the direction in this case is anti-clockwise or counterclockwise. So this configuration will be S. So there are two examples over here. The first example, I have already assigned the priority groups to these atoms around the carbon. The first one is chlorine, second one is oxygen, third is methyl group, and the fourth one is hydrogen. And hydrogen is pointing away from us, which means that hydrogen is the lowest atom, or the lowest atom or the smallest atom between all these atoms that are attached to the carbon. So if we can just do it like this, it's going to be easier for us to know the rotation. So it's going to go from 1 to 2 to 3, and then the fourth atom is in the back. So we see that this direction is the anti-clockwise or counterclockwise. So the configuration for this chiral center will be S. For the second example over here, so let's just make it like this. It's easier for us to understand and assign the numbers. The first one goes to bromine, which has the highest atomic number. The second one goes to the hydrocarbon chain. Third number goes to carbon, and the fourth goes to hydrogen, as always, because hydrogen is the lowest atom. But in this structure, there is a problem. If we assign the configuration, the absolute configuration for the center chirality, the configuration will be wrong, because the hydrogen is pointing towards us and the bromine is pointing away from us, because as bromine is has the highest atomic number, it should be pointing towards the viewer, not away from the viewer. So in this case, what we're going to do is we're going to assign the chirality absolute configuration for the chirality center, and we're going to reverse it. If we have R, we're going to reverse it to S. If we have S, we're going to reverse it to R. For example, based on this number that we have assigned already, the configuration is S because it's counterclockwise. But since the hydrogen is pointing towards us, we need to reverse this S to R. So the final answer is R. So thank you so much for watching this video. If you learned something, please like and subscribe to my channel. Have a nice day. Bye-bye.